Bismillahirrahmanirrahim. Assalamu alaikum. Exercise 10.1, question number 1. In this question, we are given a diagram like this. And in this diagram, AB is congruent to CB and angle 1 is congruent to angle 2. And we have to prove that this in this diagram, triangle ABC is congruent to triangle CBE. So, first of all, we will take the correspondence of two triangles. And these two triangles are triangle ABD and triangle CBE. In the correspondence of these two triangles, AB is congruent to CB because it is given to us. And angle 1 is congruent to angle 2. It is also given to us. And we can see that in this diagram, angle ABD, which is this angle, angle ABD, and angle CBE, which is again the same angle, this one. So these two angles, definitely it is angle B. So it is same angle. We're talking about the same angle. So angle ABD and angle CBE, they are the same angles, which is angle B. So by the reason of self-congruency, these two angles are also congruent. So we can see that by side angle postulate, triangle ABD is congruent to triangle CBE. So in this way, we have proved that these two triangles are congruent to each other. Now let's move to question number 2. In question number 2, the data is that from a point on the bisector of an angle, we are given an angle ABC. We take an angle ABC. Here you can see in the diagram. Perpendiculars are drawn to the arms of the angles. Here the perpendiculars are drawn. One perpendicular is this and the other is this. And we have to prove that these perpendiculars are equal in measure. That is, at the end, we have to prove that EF, perpendicular EF, is congruent to perpendicular CG. So we can take the correspondence of two triangles, which are the right angle triangles in this diagram, triangle EFB and triangle EGB, and we will prove them congruent by the side angle postulate. And EFB, angle EFB is congruent to EGB because both are right angles. And angle EBF and EBG both are also congruent because we have drawn a bisector BE, and as it is a bisector, so it is dividing an angle into two equal parts, and BE is congruent to BE because it's the common side. So these two triangles are congruent by the side angle postulate. So whenever two triangles are congruent, all their corresponding sides and all the corresponding angles are congruent to each other. And by this, we can say that EF is congruent to EG because these two are the corresponding sides of the congruent triangles. And these two are the perpendiculars in these two triangles. So the perpendicular which has been drawn is the perpendicular which has been drawn to the arms of the angles. These are now proved to be equivalent. Now, we move to the next question from exercise 10.2, question number 1, which is like prove that any two medians of an equilateral triangle are equal in measure. So we take an equilateral triangle ABC. As it is equilateral, so all their sides are congruent, and we have drawn their medians BD, EC, and AE. These are the three medians. We can see that AB is congruent to AC because it is an equilateral triangle and all the sides are congruent. So AB is congruent to AC. We can multiply on both sides by 1/2. So half of AB will be equivalent to half of AC. And when we see in the diagram, half of AB is equal to BF and half of AC is equal to DC. Well, we keep this result and we will be using it in the next step. Now we take the correspondence of triangle BFC and triangle CBD. And in these two, the correspondence of these two triangles, we can see that angle CBF and angle BCD both are 60 degrees. Because in any equilateral triangle, all the three angles are ever 60 degrees. They can't be other than 60 degrees. And we can take the next result. BF is congruent to CD. We have already proved it here, that BF is congruent to CD. We have already proved it. And BC is congruent to BC. These are the common sides. So these two triangles, BFC and CBD, because of the side angle side postulate, they are congruent to each other. And whenever two triangles are congruent, all their corresponding sides and angles are congruent to each other. So we can write FC is congruent to BD, the corresponding sides of the congruent triangle. So we can see in the figure that FC, which is this one, FC and BD. So we can see that these two are the medians. So these are congruent to each other. So and we have proved that any two medians in an equilateral triangle are congruent to each other. Now we will move to the next question, which is from 10.3, and it is question number 1. In this, we are given a diagram, and in this diagram, we can see that we are given that AB is congruent to CD and AD is congruent to BC. And we have to prove that angle A is congruent to angle C and angle ABC is congruent to angle ADC. So it's very simple to prove. We will take the correspondence of two triangles ABD and CDB, and we have named a few angles here: angle 1, angle 2, angle 3, and angle 4. Now, in the correspondence of these two triangles, AB is congruent to CD and AD is congruent to BC because these two are given to us. And we can take the third side, BD, congruent to BD because it's the common side and it's self-congruent. So these two triangles are congruent because of the side postulate. So now their corresponding sides A and C are congruent to each other. Sorry, corresponding angles are congruent to each other. And similarly, angle 1 is congruent to angle 2 and angle 3 is congruent to angle 4. These are also the corresponding angles of the congruent triangles. Now from this result A and B, we can add the left hand sides. And so we have to add the right hand sides. So angle 1 plus angle 3 will be equivalent to angle 2 plus angle 3. And when we add angle 1 and 2, we get angle B, angle ABC, and when we add angle 2 and angle 4, we get angle D, which is angle ADC. So in this way, we have proved both the results. The first one here we have proved angle A is congruent to angle C, and here we have proved that the angle ABC is congruent to ADC. And now we move to the next question, which is question number 2 from the same exercise 10.3. Here we are given a diagram, and in this diagram, angle LN is congruent to MP, angle MN is congruent to LP, and we have to prove that N is congruent to P, and angle NML is congruent to PLM. So by just proving the congruency of the triangles, we can prove both these results. It's very, very simple. We take the correspondence of these two triangles. We collect the results. LN is congruent to MP and MN is congruent to LP. These are the two given sides which are given to us congruent. And we take the third side, LM is congruent to LM because of the common sides. So these two triangles are now proved to be congruent because of the side postulate, side postulate. Whenever there are two triangles are congruent, so all the corresponding angles and sides are congruent. Because of this, we can say that angle N is congruent to angle P because these are the corresponding angles, and angle NML is congruent to angle PLM because these are also the corresponding angles of the congruent triangles. Now, a question from 10.4. In this, we are given a diagram PAB, a triangle in which PQ is perpendicular to AB and PA is P and PB, they are congruent sides. And we have to prove that AQ and BQ are congruent sides, and angle APQ and BPQ are congruent angles. Again, we will prove the correspondence, the congruency of these two triangles APQ and BPQ. And as they are the right angle triangles, so we can prove it by hypotenuse side postulate. So we will prove the hypotenuse and one side of these two triangles as congruent. We know that PA is given to us congruent to PB. It is given to us an angle AQP and BQP both are 90 degree. So they are congruent to each other because it is given to us that they are perpendicular. And PQ is congruent to PQ. There's the common side. So these two triangles are congruent because of the hypotenuse side postulate. So their corresponding sides AQ and BQ are congruent, and their corresponding angles APQ and BPQ are also congruent to each other. And now move to the next question, which is 10.2, question number 2. Again, we are given a diagram, and here you can see 90-degree sign. So these are the right angle triangles. So again, we will prove it by hypotenuse side postulate, because these are the right angle triangles. In this figure, angle C is congruent to angle D, and both are 90-degree. And BC and AD are congruent sides. And we have to prove that AC and BD are congruent sides, and BAC and ABD are congruent angles. So we can take the correspondence of these two triangles, ABD and BAC, and we can see that angle D and C are given to us congruent, side AB and BC are given to us congruent. We can take AB and congruent to AB, the third side, and we can, by doing so, we can prove the hypotenuse side postulate. These two triangles are congruent, and their corresponding sides, AC and BD, they are congruent. These are the corresponding sides of congruent triangle, and their corresponding angles, BAC and ABD, they are the corresponding angles of the congruent triangles. So they are congruent to each other. Thank you so much.